Alright, so the third example we have y equals 4. So we're going to take that 4 and plug that in everywhere over here for y, because we already know the y value is 4. It means the ordered pair be 0, 4, 1, 4, negative 1, 4, and negative 2, 4. So my domains would be negative 2, negative 1, 1, and 0. And the ranges are all 4s, so I'll just write it one time. You can plot your points. So we have 0, 4. So don't go left or right, any, just go up 4. 1, 4, negative 1, 4, and negative 2, 4. So anytime you have a line that's y equals and it's just some number, you're going to get a horizontal line like that. Alright, so this time we have a fraction as a coefficient. Same thing though. Let's plug these numbers in for x. So we have negative 1/2 times 0 plus 5. That gives you 0 plus 5, which is 5. So the first order pair would be 0, 5. Okay, negative 1/2 times negative 2 plus 5. Negative 2 is over 1, so that's really like 2 over 2, which is just 1. Becomes positive because 2 negatives multiplied give you a positive. You get 6. So we have negative 2, 6. Okay, and then we have negative 1/2 times positive 2 plus 5. Negative 1 plus 5, which is 4. So positive 2, positive 4. So we have negative 1/2 times positive 4 plus 5. It gives you negative 4 over 2, which simplifies to negative 2 plus 5. Your answer will be positive because 5 is bigger than 2. You get 3. Alright, so your domains would be negative 2, 0, 2, 4. Your range would be 6, 5, 4, and 3. Let's plot the points. So 0, 5, negative 2, 6, 2, 4, and then we have 4, 3. And that makes a line, so we got it right. Alright, so the next few examples we're going to look at sample SOL questions. What is the range of the function y equals negative 2x plus 5 if the domain, we know domain is x, is negative 1, 0, 1, and 2. Same thing, just plug in your x values. So we have y is equal to negative 2 times negative 1 plus 5. That gives you positive 2 plus 5, which is 7. So we have a range of 7. Negative 2 times 0 plus 5, which is 0 plus 5, and that gives you 5. So a range of 5. And we have negative 2 times 1 plus 5. It gives you negative 2, so that range would be 3. So again, to get the range here, I'm just taking my domains, the x values, and plugging them in here for x. And finally, we have negative 2 times positive 2 plus 5. Negative 4 plus 5 is 1. Alright, so number 6. Which rule generated the table below? Take your x values and plug them in, see what works. So A. If we plug in 0, for y and 0 for x, because the first order pair is 0, 0. Let's see if that works. 0 equals negative 3. Nope, not true. So A is not correct. Let's look at B. 2 times 0 plus 3, and that should be equal to 0. I wrote that kind of backward. Let me fix that for you. So 0 equals 2 times 0 plus 3. That would give you 0 equals 0 plus 3. Again, 0 does not equal 3, so get rid of B. Let's look at C. So plug in 0 for y, 0 for x. 0 does not equal 2, so C is not right. So we know D has to be right, but let's check it to be sure. So if we look at 0, so the y value is 0, plug in 0 for x. Negative 4 times 0 is 0, so that works. Let's keep going. Negative 4 times positive 2 does give you negative 8. Negative 4 times negative 1 is positive 4. Negative 4 times positive 1 is negative 4. So yeah, D is the correct answer. Alright, number 7. Which ordered pairs are on the line of the function y equals 3x minus 4? So we'll take these x and y values and plug them in. So A is 19 for y, and 3 times negative 4 minus 4. It's negative 12 minus 4, which is negative 16. So that's not correct. Let's try B. So we have negative 4 for y, equals 3 times 0 minus 4. And both sides are equal, so that would be correct. Because it has this s right here, let's be sure that none of the others work too. So C, y value of negative 10 equals 3 times negative 2 minus 4. 3 times negative 2 is negative 6 minus 4, which is negative 10. So C works. D, run out of space here. Sorry about that. So the y value is 10 is equal to 3 times 5 minus 4. That's 15 minus 4, which is 11. So D does not work. So the correct answer for number 7 would be B and C. Alright, last couple of examples. So this time you're given a graph. If you remember last class, we talked to you guys about a line, how it continues on forever and ever and ever. That means that the domain of ranges, the x values would keep on going to positive infinity and negative infinity. There are infinite solutions. So you could say all real numbers for domain of range, or you could get ordered pairs. So I'm going to try to find a few ordered pairs from the line. So we have like negative 1, negative 2, 0, 1, and 1, 4. So my domains, and you could get another ordered pair too, but we'll just use those 3. Negative 1, 0, 1. And the ranges would be negative 2, 1, and 4. Alright, last example. So let's get some ordered pairs. So I see an ordered pair right there, which would be 0, 2. We can take this ordered pair and plug it in for the x and y values and see which choice works. So A. So A, we have 2 for y is equal to 0 minus 3. That gives you negative 3, so A is not correct. Let's look at B. 2 times 0 plus 2 does give you the y value of 2 because that'd be 0 plus 2. So both sides there would be equal. Let's look at C. Just glancing, it looks like C and D would work if you plugged in 0 also. Let's get one more ordered pair and try it out. So we'll try out 1, 0. So if we plug in 1 and 0 for B, 2 times 1, get the x value plus 2. That would be 2 plus 2, which is 4, so that's not going to work. If we try C, negative 2 times positive 1 plus 2, that gives you negative 2 plus 2, which is the y value 0. So C would be the correct answer.